So now we're going to talk about solving exponential and logarithmic equations. All right, so this is our section 6.5. And so just a few things I want to talk about before we start solving is if you remember, now we're talking about if b, this right here is positive, it's greater than 0, and it's not equal to 1. All right, so those are the only two exceptions for this. But we already talked about this exponential rule. When these bases are the same, then x is going to equal y, right? Then I can claim x equals y if the bases are the same. Well, kind of the same thing here with the logs. If x and y are positive, all right, so these two numbers are positive, that means it can't be a negative number. Then if I have log b of x equals log b of y, I can pretty much cancel out these log b's and have x equals y. All right, so this second rule right here is something I'm going to use right now on this exponential part. So those will come into play. You'll understand a little bit more as we go through and solve some of these exponential and logarithmic equations. All right, so here, remember what our goal is to solve for x. So we want to find what x is on this. Well, we can't figure that out. So what we're going to do is we're going to go ahead and we're going to put this into an equation where we can solve it. So we're going to use this. And what this is saying is I can put a log in front or natural log. If I have an e, I would use a natural log. So I can fairly put a log base 10 in front of this if I do that log base 10 in front of this. So if I put a log in here, I can also put a log in here. All right. Now, once I do that, I have to use some of the properties of logarithms to solve. So first thing, just be aware, I can put a log on this side, just have to be sure I do it to both sides. Okay, that's something, that's a rule you can do. Now, because I have an exponent, I'm going to bring this down to the front. That's the power rule that we learned in 6.3. So we're going to bring that x down. And now it's just kind of an algebra problem. We're trying to solve for x. So if I want to get x by itself here, I'm going to divide by log of 7. And here we're going to divide by log of 7. Kind of like that change of base formula, right? So when you divide those both out, you're going to get approximately, it doesn't really, you're going to get approximately 1.2, we'll just say 1.28. All right. Now this would be left in exact form. If I said leave in exact form, and this is in approximate form. All right, so sometimes you'll be asked to do one or the other, but obviously it's approximated because we have to round. All right, so let's look at some more problems. We're just going to solve problems exponentially and with logs. So let's start with this one. Let's go with this one, number 2. So we have these exponents. So let's use what we learned here. Let's go ahead and put a log, because there's nothing really we can do here. So we just got to get these out of the x, we got to get these out of the exponent. So let's go ahead and just use our log on that. So we're going to go ahead and put a log in front of both of them. All right, now we have to use our properties of logarithms. So let's go ahead and use our power rule and bring this one down just like we did above. So we're going to bring a 3x plus 1 down, put it in front, I'll put that in parentheses, put it in front of our log 2. Do the same thing here. Let's bring the 4 minus x down to the front as a coefficient. All right, so that none of that's new aside from adding in the log so that we can solve that. So now it's just pretty much algebra. And you guys are really pretty good with your algebra. We want to distribute this log 2. It's really log base 10 of 2, right? We want to distribute that through. So we're going to take 3x times log of 2. Okay, plus, we'll distribute that through 1 times log of 2. Same thing over here. We're going to take 4 times log of 3 minus x times log of 3. Now, because we're solving for x, just like we would with any equation, we just want to get anything that has an x on the same side. So would you agree that if I added this one that has the x That would eliminate it over here. Okay, so I'm going to do this in 2 steps. So I might later do this in 1 step, but here, so we're going to have 3 log 2. Whoops, forgot my x there. 3x log 2. I better rewrite that. Okay. All right, so we have 3x log 2 plus x log 3. Still have this log 2 here equals 4 log 3. All right, so all I did was eliminate this, so I had to add it to both sides. Well, these two have an x, so I need to eliminate this, get rid of it, because I only want the ones that have x's on one side. So I'm going to subtract log 2, subtract log of 2. So what I'm left with is a 3x log 2 plus x log 3 equals 4 log 3 minus log of 2. Now notice these are all base 10, right? They're all the same logs. They all have the same base. That's important. All right, so now we're going to take out what would be a greatest common factor on that. So you see what they have in common, right? So we're not really going to take out a log. That's not a greatest common factor. That's not a factor, all right? A log isn't. So we don't look at taking a log out, but we are going to take an x out of that. So if I factor an x out of here, I'd be left with 3 log 2. Divide an x out of here, and we're just left with log 3. If you want to check it, just multiply it back through. Don't do anything on the right side. All right, well, just like I would anything, if I take x times something and I want to get x by itself, I'm going to divide all that by 3 log 2 plus log 3. Then I have to divide this side by that. Okay, so this just becomes x equals, and we're going to do an approximation. And so this just comes from putting in your calculator. And I will tell you, a lot of errors come from that. If I said exact form, you would leave it like this, but I would have you take that to a decimal. So let's just take it and round it to maybe 2 decimal places. How about that? So I'm going to show you how to put this in to decimals. All right, so let me, I think I have decimals pulled up here. Let me double check. Yeah. All right, so here, let's go ahead and put in, so we're going to start with a parenthesis, and then you can kind of look at your notes and follow me with that. So there's a parenthesis, we're going to go, what do we have here? 4 log, so we have 4, and then function will go log of 3, and then put the parenthesis, minus log 2. And then notice we have to put 2 parentheses. All right, now we're going to take that and we're going to divide it by parentheses. I always start with the parenthesis. 3 log 2 parenthesis plus can't even see my plus there. Let me pull this up. Plus log 3. 2 parentheses, right? So take a look, and that's how you want to put that in your calculator. It's hard to get the right answer sometimes if you put them in incorrectly. So I just wanted to show that to you. So the answer is approximately 0.17 if we round to 2 decimal places, right? Okay, so really pay attention. Decimals is so easy to use. I mean, I really like using that even more than and I'm a big TI-84, maybe 384, but all right, so let's keep moving on. We're going to do another problem here. And so we're going to go on with, let's do number 3. And this is exactly like the one that we just did pretty much, but we'll go ahead and do one more example like it so you've seen a couple. All right, so first thing I have to do, you can kind of think about it. And if you want to try and do this just like we did and then come back, just pause it, that'd be great. All right, so we're going to throw a log in front of it. All right, now I can use the power rule, and I can bring this down as to the front. So we're going to have an x minus 4 log of 3. I think it's easier to keep that in parentheses just so. Log of 7. Okay. All right, now we went to go ahead and distribute through. So here we have x times log of 3 would be x log 3 minus 4 times log 3. Same thing here, distribute the log 7 through, log of 7. So 2x log of 7 plus 5 log of 7. All right, so now let's turn my camera here so we're straight. There we go. So let's go ahead and get everything with an x on one side. Now this time, unlike last time, I'm going to do this in one step. So I'm going to subtract this to eliminate it. Then I'm going to subtract it over here. Okay. So that's going to give me x log 3 minus 2x log 7. And then I'm going to move this. I want to eliminate this. And I have to add it over here, right? Just to keep it balanced. If I add it here, I have to add it here. So then over here, we're just going to have the 5 log 7 plus 4 log 3. So all I did is get the x on one side. I moved this, so it's together, this over here. Okay? All right, now let's take here, we're going to factor out an x. Greatest common factor, and take out an x. So we'll have x log 3 minus 2. If I divide that by x, the x just comes out. And again, we just leave this alone. And then we divide to get x by itself. Okay, these cancel. So here's what x equals. So I'm going to let you go ahead and figure out if you can do that. I'm not going to do that on the calculator, save some time. But I will tell you it's approximately negative 5 point, I have 057, so we'll just leave it that, 057 approximately. So see if you can get close to that. It's okay if you're a little off over here, but see if you can get as close to that as possible. All right, so let's do one more here. So this is number 4 that we're doing on our exponential. So let's do e to the 0.5x equals 3 to the 1 minus 2x. Okay, if you can read that. All right, so it's the same thing, the only thing that's different on here is if you notice, we're dealing with an e, and that means we're working with our natural logarithm. So instead of using log, we're going to use L of n, okay, the natural log. So we'll just put a natural log in front of both of these. So we have natural log, L of n, 3, just like we did with the log. And how I know to use natural log is because I have an e. All right, so now do the power rule. So we're going to bring this down. So 0.5x, natural log of e, is equal to 1 minus 2x, natural log 3. Okay, so this side does not change. Here we're going to distribute, so natural log times 1, natural log of 3 would be natural log of 3. Okay, minus 2x, natural log of 3. So notice I don't have to show the 1 in front of there. You can, but you don't have to. All right, so let's get everything with an x on one side. So that means I'm going to add 2x and I'm going to add it over here. All right, so I'll leave what I have here. And here I'm going to add 2x. And then I'm still left over here with the natural log of 3. So all I did, again, I'm not showing this part where I'm subtracting. I just added plus 2x natural log of 3, and I've added plus 2x natural log of 3 over here. This becomes 0. All right, take the x out. So now to get x by itself, remember you have an e on your calculator. It's on the left side there. You can find it if you're using an 8384. All right, And that's what x will equal. This cancels out. We just divide. So in this case, it should be approximately, and you can see if you get this, 0.407. So you can try that on your own and see if you can get 0.407 by putting that in. Okay. All right. So let's move on. And now we're going to just talk about, the first part was was exponentials. So now we're going to talk about logarithms. All right, so here we're going to work on the logarithm part. So let's do first problem here. Let's see. So here we're given these in log form rather than exponential form. That's the only difference. All right, so what's nice is these all have the same log and same base. So when we go to solve that, first of all, we have to look, we're not adding any logs because they all have them. So we just look up here and we notice we have a subtraction. So do you remember in our properties of logarithms, a subtraction is the quotient. So we're going to rewrite this as a single logarithm, log base 3, x plus 6 over x plus 2. And that's going to equal log of 3, log base 3 of x. Log base 3 of x there. All right, now here's kind of the cool part, and this was what we were talking about in our previous notes right here. So I'm pull back over here. Is when we have this, right, we can pretty much cancel these out and have x equals y. So when we look at this down here, I can now, because I can divide both of these by log base 3, excuse me. So if I divide these both by log base 3, these pretty much just cancel out. And then we're just left with an algebraic problem. Like this. That's the best part. So now I want to get this out of the denominator, so I'm going to multiply this times x plus 2. It's just algebra. But what I do here, I have to also do here, right? So these cancel out, and we're left with an x plus 6. I'm going to distribute x times x times 2. Now we want to set that equal to 0. So I'm going to subtract x. I'm doing this in one step. And I'm going to subtract 6. So 0 equals x squared plus 1x minus 6. So I just got everything on one side and set it equal to 0. So now solving this is just a quadratic, so we can factor this. So whatever multiplies to equal 6, we can get 1. Whoops. Okay. So 3 and 2, and we need a positive 1, so it's a positive 3 and a negative 2. Now I set each of those equal to 0. So x equals a negative 3 and x equals a positive 2. All right, now I want you to think about back up here at the original. If I put a negative 3 in here, I end up with a positive number, so that's okay. But if I put a negative 3 in here, that would be a negative 1, right? Negative 3 plus 2. You cannot take a log of a negative number. Now you can have a negative exponent, that's different. But I can't take a log base 3 negative 1. I can't do a negative number, so therefore that solution will not work. It's an extraneous solution, and this is the one that will work. Okay. All right. So let's do a couple more problems here. So this one is going to require you, okay, so let's take a look at this one. This, might have forgotten how to do this last part. We'll talk about it, but all right, so here's our log. All right. So notice this one does not have a log like the last one did. So you could say, okay, well, I'm going to put a log in front of it. But if I do that, I'd have to put a log in front of these two. So I already have one there. So that doesn't help me to do that. That makes sense? It doesn't help because if I add a log here, I got to add another log over here, and I don't need one here. So what are you going to do in this case? Let's go ahead and just, before we do anything else, let's go ahead and use this properties of logarithm. So if this is an addition, that means we're going to use the product rule. So let's go ahead and simplify that first and write it as a single logarithm. Right, that means multiplication, so we're going to multiply All right, now this is just a normal logarithmic problem. So what is the base here that's not showing? It's a 10, that's a common logarithm. So what this is saying, how I solve it, is I'm going to take the base right here. So 10 to this power equals this. Right? The base to the power, so 10 to the 1 equals this. So now we can finish solving that. Again, it's just an algebraic problem. We want to multiply these two binomials through, so you can FOIL it, distribute it, however you want to do that. So 3x times x is 3x squared. 3x times a negative 1, 2 times x, 2 times a negative 1. All right, so combine like terms here. So negative 3 and positive 2 is a negative 1x, and that equals 10. So we want to set it equal to 0. So let's do that. There we go. All right, I don't have a greatest common factor. And if I use the AC method, 3 times a negative 12 is a negative 36. Are there factors of 36 that would give me 1? There are not. So that means you either need to complete the square or use the quadratic formula. So I'm going to use a quadratic formula. Oops, x equals, let's see here, negative b squared minus 4ac all over 2a. So let's see if we can solve for x this way. So what we're going to have here is a negative b, so b is a negative 1, right? So negative, negative 1. Okay, b is a negative 1, so we take negative 1 squared minus 4. A is 3, and c is a negative 12. And we'll take that all over 2 times a, and a is 3. All right, so let's simplify that. Let's see here. So we have a positive 1. So this negative 1 times negative 1 is a positive 1. Negative times a negative is a positive. 12 times 12 is 144 all over 6. So this is 1 plus or minus square root of 1 plus 144, 145 all over 6. And that I would just leave in exact form. And there's two answers. There's a 1 plus and a 1 minus. All right, so we'll just leave that one in exact form. If it asks for an approximation, then you just put 1 plus square root of 145 divided by 6 into your calculator, and then 1 minus square root of 145 divided by 6 in your calculator, and you'll get two answers. All right, so let's move on. Number 3. All right, so here we have f of x All right, so what they're telling you on this one is that f of x equals 0. So all that means is in place of f of x, we're going to put a 0. So that's just a different way to say set it equal to 0. All right, so we kind of want to we're solving for x. So let's go ahead and just get rid of this 15 because we're trying to get this x by itself. So let's go ahead and just add 15. All right, so when I think about this and we want to maybe divide, so I could take this coefficient and divide this by 3. So just kind of keep using this algebra, right? These 3's cancel then. So let's think about how we're going to set that up. So if we want to solve that, let's put that into exponential. So we take the base to this power equals this, right? So base to this power equals this. Well, I think we can solve that if we divide by 2. So 2 to the 5th, 32. So x is equal to 16. And if I look back here, it's perfectly fine to put a 16 in there. It doesn't give a negative number, so we're all good. All right, let's do this one. A couple more here and we're about done. All right, so we have 3. All right, how about that? Oh, how about this one? So you think, well, I want to put a log in front of both of them. We already have a log, can't do that, right? But one thing I can do is I can go ahead and divide this by 3. So that would give us a log x, these cancel, equals 2/3. Okay. So now let's go ahead and think about solving this. What's my base here? Base is 10. So we're going to take 10 to this power equals this. So you can put that into your calculator or you can leave it in exact form. Exact form would be 10 to this power, this root, right? Power over root. So 10 squared is 100. 10 squared is 100, and then this would be the cubed root. And that's exact form. Or you can put it in and get an approximation as well. All right, now let's look at this one. How about a natural log here of 2x equals 5? All right, so this is just a basic one. It's already gotten where we did this one. It's already to this point right here. That's where we're at. So all I do here, what is this base that's not showing? Well, if it's not showing, it's with the natural log, it's an e. So we're going to take this base, which is e to this power, equals this. And then we want x by itself, so we divide by 2. So in your calculator, you can take e to the 5th divided by 2, but this is the exact answer if you leave it as an exact answer. All right, I just have one more problem that I want to go through with you. I think I have room here. Okay, so let's do this last one here. I just wanted to work a natural log with you. All right, so let's take a look at this one. So notice what's nice, they all have a natural log. So that's eventually going to be able to cancel out. We're going to cancel that out. But our first step there is when we think about what this is, let's go ahead and just bring that, use our product rule, power rule, excuse me, and bring that down to the front. All right, so when I bring this down to the front, let me think, oh, you know what, this, we don't bring that down to the front. This right here, e to the natural log of x, that is just going to equal the natural log of x. So you know what, we're not going to do that one because I'm not going to test you on that. I mean, we would do that if we were doing our face-to-face courses, but because we didn't talk about that rule, that's not going to be on your test. So sorry about that. I forgot that we didn't cover that earlier, so we'll skip that one. Okay. So, and because I skipped that one, I'm going to have you try one more. I know you're probably ready to go. You're tired of listening to me, aren't you? All right. So let's look at this. Sometimes they look a lot more difficult than they are. But what you're doing is pretty cool. You are solving equations with variables in the exponent. That's pretty cool when you can do that. All right, so let's take a look at that one. So first thing we want to do is go ahead and get rid of the 1. So we'll subtract 1. You could probably do this without my direction now. Okay, so next step, let's get rid of this 5. So we're going to divide this by 5. So we have 1.2 to the 3x minus 2 equals 2. All right, so how do you suppose, kind of thinking about where you would go from there? Okay. So let's think about our power rule. So we're going to bring this 3x minus 2 log of 1.2 equals 2. Okay. So here's what I did that I forgot to tell you. We're going to put a log in front of this, but then that means I have to put a log in front of this too. Skip that step. So put a log in front of this, put a log in front of this. Then, because there's a log here, I can do the power rule. Okay, with me there? Now I would probably keep this in parentheses when I bring this down, because now you're going to have to distribute that through. All right, and then there's a couple ways of doing this. I'm just going to have you continue. I mean, I could just divide both sides by log 1.2 since I don't have an x value over here, but I just want you to get in the habit. So I'm just going to go ahead and do it this way. We're going to distribute through. There's a couple ways that you can solve this, but so this times this and -2 times this. Okay. So because we're solving for x, right, we're going to solve for x here. I'm going to go ahead and add this to the other side. So we have 3x log 1.2 equals, I'm going to add, because it's a subtract, I'm going to add it over here. So log 2 plus 2 log 1.2. All right, so a couple things. You can then divide by, if I want x by itself, I'm just going to divide this by 3 log of 1.2. 3 log of 1.2. And that gives you x is approximately, so here's your exact answer. I think I did this earlier, I think I have a answer for you. I think approximately 1.934. So you can see if you can get that on your calculators when you do that. All right, that is all I have for you on 6.5. So good luck with that. Let me know if you have some questions. All right, have a good night.